Now we're going to look at solving a system of inequalities that's got two variables, x and y. So how we solve for a system of inequalities, guys, is actually by doing the graphing and the shading of the solutions. Just like a system of equations, you need an ordered pair, a point for x and y, a value for x and y that makes the equation true. So for an inequality, you need an infinite number of solutions or an infinite number of ordered pairs that would make the system of inequalities true. So we shade to show that all of those points in that region would be a solution to your inequality, to both your inequalities actually. So let's go ahead and do some examples. The steps above there are for you guys to sort of help you through the process in doing this. So anytime you're graphing in general, you have to make sure your inequalities are in slope-intercept form. So they have to be solved for y. That's the first step. Then you would graph them like you normally would, starting with your y-intercept, paying attention to your slope. So the only thing you guys have to make sure you're checking here is if your lines are going to be dashed or solid. So we just mentioned it on that first page, but if it's less than or greater than, it's dashed. If it's less than or equal to or greater than or equal to, that's when it's going to be solid. And then we'll talk about shading, but that's the last step. Shade both of your lines, the correct region for each inequality to represent your solutions. So the first one's nice because it's already graphed for us. So y is greater than negative 3x minus 1. So we're going to start at negative 1. And our slope is down 3, right 1. Remember, we're either going up or down, but always right. And that is equal to, that's what that little line underneath there means. So for this one, we are going to have a solid line. That means that the ordered pairs on that line are going to be included as part of the solution for that individual inequality. So we need to test a point. So I always like to test 0, 0. So 0, 0 would be right here. As long as it's not actually on your line, you may test it. So if we test, I just always would like to write the ordered pair that I'm plugging in. Plug in 0. It's just the easiest point to plug in if you can. 0 is greater than or equal to negative 3 times 0 minus 1. So 0 is greater than or equal to negative 3 times 0, which is 0, minus 1. So 0 minus 1. 0 is greater than a negative. So because it's true, that means 0, 0 is a solution. So if 0, 0 is the solution, that means that whole entire side also would have to be where all the solutions are. You're basing it off of which side. So then we need to graph our second line. So y is less than x plus 2. So we're going to start at 2. And our slope is 1x. Remember, even though you don't see a number in front of the x, it is a 1. And because that's not an equal to, it's just less than, we are going to have a dashed line. And we're going to test 0, 0 again. So 0, is it less than 0 plus 2? 0 is less than 2, so it's true. So since 0, 0 is on this side of the line, and it's true, all the points on that side of the line must be a solution. So we're only concerned with the ordered pairs that would be true for both of our inequalities. So this section up here are just a solution to that first inequality. These ordered pairs are solutions to the second, but that overlap is where the solutions for both of your inequalities are. So any ordered pair you pick in that section would be an ordered pair that would work for both of these inequalities. So either you can write solutions in your overlap section, or just make sure that I can tell that that is where the overlap is happening. So let's go ahead. You guys can try that second one. And I am going to do this third one with you. Since there's 3 inequalities here, x is greater than 1, y is greater than or equal to negative 3, and 4x plus 3y is less than or equal to 12. So these first 2 are ready to be graphed. We have to remember how to graph those weird horizontal or vertical lines without like slopes or something, but we can do that. So let's do that first. So for x is greater than or equal to 1, remember if it's x values, it needs to be all the x values to the left or x values to the right of 1. So in this case, since it's greater, they're going to be to the right, but your line has to go through that variable. So if it's x is greater than or equal to 1, that's your x value of 1. It's going to be a solid line. And if we want all the values that are greater than 1, it's to the right. Okay, how about your second one? Y is greater than or equal to negative 3. So where is y equal to negative 3? Right down here. And it too is a solid line. And if we want the y values greater than, that would be everything above your line. You can plug in a test point, but if it's just talking about y, which direction is y greater than negative 3? Above. The last one we do have to solve for our y, so let's do that. So I'm going to subtract the 4x. And get 3y is less than or equal to negative 4x plus 12. Divide by 3. Every single thing, remember. You can do 2 separate fractions, or you can just do the whole right side by 3, whatever kind of works for you guys. But everything in the equation has to be divided by 3. So y is less than or equal to, I'm going to keep that as a fraction. You don't want to divide 4/3 and get a decimal because you can't graph a decimal slope. You can graph a fraction slope though, so keep it as a fraction. 12 divided by 3 is 4. So we're going to start at 4. And our slope is negative 4/3. So down 4, right 3. And that too is a solid line. So you guys can plug your test point in. I want to show you another way though also. This inequality is less than. Anytime you have less than or equal to, you guys always shade below your graph. If it's greater than or greater than or equal to, you shade above. Because really what happens when you're plugging in that 0, 0 point, you're always ending up really looking at that y-intercept because that's the value left. So like for our example here, y is less than -4/3 x plus 4. Which way is less than +4? This way or that way? Well, less than is going to be below. So because it's less than, I kind of just know that my shading is going to be below, or like the bottom half, if you will, of that line. So you can test a point, or you can kind of visually look at it and understand if it's less, below, if it's greater, above. And that is what we did up here. For the first inequality, it was above your line. For the second inequality, it was below your line because it was less. So you can kind of visually look at that and see too without always having to test the point. So now that we're done shading, where are our solutions for this inequality? Right here in the middle. Again, I like to kind of write where the solutions are, but just that little triangle section in the center. So if you guys picked any ordered pair in that section, it should make every single one of the inequalities in your problem true. So I want you guys now to try the ones that are remaining. So just remember, must be solved for y. Then you just graph them like a normal line. Pay attention to if it's dashed or solid, and then do we shade above or below. So go ahead and try the remaining ones.